the derivative of the trigonometric functions. Our objective in this lesson is to differentiate trigonometric functions. These are the derivatives of the 6 trigonometric functions. Memorize these. You will need to know them like the back of your hand, like the unit circle. Memorize them. The derivative with respect to x of the function sine of x equals cosine of x. And the derivative with respect to x of cosine of x equals negative of the sine of x. Why are these functions these derivatives? Well, we can think of some reasons. One good way to think about it is if we think about the graph of each function. Let's take a look at the sine function. If I graph y equals sine of x, starts at 0, and it looks like that. What does derivative mean about the graph of a function? Well, it's slope, of course. So if we think about graphing the slopes at each point, well, we start with the horizontal tangents. At the maximum, the slope is 0. At the minimum, the slope is 0. At all of these little hills and valleys, there's a horizontal tangent, so the slope is 0. At the origin, at x equals 0, if I draw a tangent line, the slope is positive, so up here. And between those two horizontal tangents, the slope is negative, so I would graph it down here, and so on and so forth. So let's connect those points that we have so far and notice what that function looks like. That's right, cosine of x. So we can think about it all about slope. Ultimately, though, we need to memorize these derivatives. The derivative with respect to x of tangent of x equals secant squared x. The derivative with respect to x of cotangent x equals negative cosecant squared x. The derivative with respect to x of secant of x equals secant of x times tangent of x. And the derivative with respect to x of cosecant of x equals negative cosecant x cotangent x. Now, when I'm trying to memorize something, I try to think of ways to see groups and relationships, such as on the bottom here, I've put all of the co-functions. Up here is sine, down here is cosine. Up here is tangent, down here is cotangent. Up here is secant, down here is cosecant. Notice what's in common with all of these co-functions. They have negative derivatives. All of the co-functions have negative derivatives. What else is a connection that we can make? The tangent family, meaning tangent and cotangent, if we group those together, notice both of those have the squared in it, secant squared and cosecant squared. Also, in the secant family, secant x and cosecant x, they have themselves in their derivatives. Cosecant x, I see cosecant x in the derivative. So some things to help you remember if you group the ideas together. Let's look at some examples on how to use these trig derivatives. Find the derivative of each function. Y equals x plus 5 times cosine x. So my derivative dy dx equals, because this is a sum, I'll take the derivative of each term independently. The derivative of x is 1 plus 5 is a constant multiple, so it hangs out and gets multiplied to the derivative of cosine of x. Derivative of cosine of x is negative sine of x. Remember, all of the co-functions have negative derivatives, negative sine x. Now I could stop there, but of course I can clean this up a bit and write 1 minus 5 sine of x. Make sure you are putting parentheses when you mean multiply so we don't think we're subtracting. So you might make yourself a little note here that the parentheses are important in this type of situation. Let's take the derivative of y equals e to the theta times sine of theta. Now I notice I said times. I'm multiplying two functions, e to the theta and sine of theta. Here I have to use product rule. Remember what product rule looks like? F g prime plus f prime g, where f is one of the functions and g is the other function. So when I write what dy dx equals, f is e to the theta, g prime is the derivative of sine theta, which is cosine theta, plus f prime, the derivative of e to the theta, is e to the theta, times g, which is just sine theta. This is an acceptable place to stop, but often you'll see something like this factored. E to the theta is common in both terms, so factoring out e to the theta leaves cosine theta plus sine theta multiplied. Let's take the derivative of v of t, which equals negative cotangent t divided by the quantity cosine t minus 5t. I notice I said divided by. There's no way I can simplify this, so I need to use the quotient rule. Remember the quotient rule? If I call the numerator f and the denominator g, it's gf prime, or low d high, minus high d low over low low, which makes g squared. Let's apply that. V prime of t equals, starting with low, I use parentheses because I'm multiplying, cosine of t minus 5t, d high, the derivative of the numerator, negative 6, constant multiple, times the derivative of cotangent x, which is negative cosecant squared x, but this is t, so I'm using t. And notice I used parentheses, so it doesn't look like I'm subtracting from the negative 6, but I'm multiplying, minus f, the numerator, negative 6 cotangent t, times g prime, the derivative of that denominator. Derivative of cosine t, negative sine t, minus 5. All divided by g squared. Cosine t minus 5t squared. That is an acceptable answer. However, we can clean this up a bit. Like we don't have to have a negative multiplied to a negative and have this extensive amount of parentheses. So let's see how we can clean it up. Cosine of t minus 5t times a negative, so just positive 6 cosecant squared t, minus a negative because this is just one term multiplied to that binomial, so plus 6 cotangent t times negative sine t minus 5. So that helped a little bit. And then, of course, over cosine t minus 5t squared. And that's a bit cleaner. If we wanted to, we could do some other stuff, such as distributing this. But if we tried that, we're not really going to have like terms to combine, so I'm not going to worry about it here. Let's take the derivative of h of x, which is equal to cosecant of x divided by 3 pi. Now I said divided by, but notice this is just constants in the denominator, which means I don't need the quotient rule just because it looks like I'm dividing. So let's rewrite h of x, pulling out 1 over 3 pi as a constant multiple to cosecant x. Now when I take the derivative, h prime of x, I'm just writing 1 over 3 pi times the derivative of cosecant x, which is negative cosecant x cotangent x. Remember, the cosecant family has itself in it. The secant family has secant, the secant has secant, the cosecant has cosecant, and it's a cofunction, so it's negative. Some things I think about when I do the derivative. This is a perfectly fine answer as long as I'm using the parentheses, or I can get rid of the parentheses and say negative 1 over 3 pi cosecant x, cotangent x by moving the negative in the front.